So we're going to be looking here at a short little video on curl. So the curl of a vector field f, where f is f1i plus f2j plus f3k, is defined as the vector field curl of f, which is equal to nabla cross f. So we're going to be looking at the cross product. Very similar indeed to the cross product we saw previous weeks for just finding the cross product of two vectors. So we need to set up our template like so, and we're going to be looking at determinants. So we're going to have something like this, where the first column will represent the i's, the second the j's, and of course finally the k's. So how do we go about finding the determinants in this fashion? Well, just as we saw in previous lectures, to find the determinants of this, we have to start by covering up columns. So if, for example, I wanted to find the coefficient of I would cover up this column here, and I'm now left with a 2 by 2. So I would do my A, D minus B, C, and that would take me to my coefficient for I. If I wanted to find the coefficient for my J, bearing in mind of course that I need to do plus minus plus for my I, J and K, I would just cover up the J column like so, and I would be left with my A, D and then minus B, C, and that would give me my coefficient of J. Same thing again for K. If I want to find this coefficient here for K, I simply cover up this row and column, this column, and I do A, D minus B, C, and that would give me my coefficient of K. So just as we saw in previous weeks. Okay, so maybe if we have a look at an example. So in this case, our example for f would be x, y, z, I plus x, y squared j plus 3 y, z, k. If we had this example, we could still start off like we had here with i's, j's and k's, if you like, as our column headings to work out determinants. And in exactly the same way, we could cover up the I column to find the coefficients of I, cover up the J column to find the coefficients of J, and so on. So if we do that, and for example cover up this column here, we can see that we'd have delta delta y of 3y squared minus delta delta z of x y squared, which is what we should find here. And if we were to cover up the J column, we should get this, and finally the K column that was covered up, and we did AD minus BC, we should get the following. Okay, so that seems fairly straightforward, certainly if you do one or two examples. So now of course we have to just do the partial differentiation. So if we come back to here, we have to differentiate this with respect to y partially, and this with respect to z, and we see we'd get 3z minus 0, and then we move on to do the coefficients of j, and finally the coefficient of k. So if we look at the last one, for example, the coefficient of k, it's this term here differentiated with respect to z minus this term here differentiated partially with respect to y, and we should get the answer we see here, 3zi plus xyj plus y squared minus xzk. And there we have our solution for the curl of a given vector. Okay, thank you for watching.